Hello there. So I was thinking of rigging this whole project apart and reusing the controller and the battery in another project. So I already started testing another motor here, but some of you had asked on how I could build this one wheel form factor balancing skateboard. So I thought, let me just make this video, because I'm not going to make a detailed video on how I built this, because this is just a proof of concept thingy. So just to make sure that doing so will actually works, right? This is nothing. So I'm going to show you how I could do so much, so that you'll at least have enough know-how on building it. So for any balancing device, all you need is a hub motor, preferably hub motor, because if you have another motor you need little more space and you need a chain drive and all that. So use a hub motor, and what I'm using is a 350 watt BLDC hub motor right here. So the cables are running from there and comes back out here. So these are 3-phase drive cable, drive wires of the motor, and these are the hall sensor wires of the motor. So check with your motor if they have hall sensor or not, because if you do not have a hall sensor, then you cannot get high torque at low speeds, which is definitely needed in your balancing vehicle, right? So then I am using a cheap Fokker 2, which is a CFOC 2 Wesk variant. So this is a 48 volt 70 amps Wesk. So three phase output has to go to this 3 cables of this motor, of your motor, and the hall sensor has to go to this hall sensor port right here, the 6-pin port. And there needs to be a battery connection on these positive negative. Sorry for using the same color, but usually it's a red and black, which is coming from my battery, which is this is a 24 volt motor, right? Yeah, this is a 24 volt motor, and I'm using a 22.2 volt lithium polymer LiPo cell battery. So this is a 6S 5H battery, and it is connected to a loop switch here. Yeah, it's connected to a loop switch here, and then the cables are coming out from here to the Wesk, and the Wesk has a sensor. The sensor, the problem here was due to silicon shortage. I could not find a BMI 160 sensor, which is supposed to be the sensor for this. Yeah. So yeah, I was talking about the BMI 160 sensor, which is supposed to be soldered here, but that sensor was not available because of the silicon shortage which has happened. So that's why I am using a MPU 9060, I guess. So thing is, I can connect the MPU 9060 at the external port here. This port, there's one port here, if you can see it right here. But this port I am connecting to this port. I'm connecting a Bluetooth module, right? So I cannot use this port for sensor, and sensor is definitely needed for the balancing. So what I did is a workaround where I have pulled some I2C cables and the power cable from this section and connected an external sensor. Let me try to show it to you. Oh my god. Yeah, and I have connected the sensor here. this is the sensor. It's mounted here. It's perfect in terms of location. So this is an external sensor, but connected to the internal I2C 0 line. I will put a link to the patch that I had to make some changes in the software so that it will recognize this I2C port, which is actually dedicated for BMI 160 internal IMU, but I have somehow made it as an external port so that I can connect any sensor and then label it as that sensor on these lines. So you can find the patch if you want to do this. Otherwise, you can simply connect a sensor to the external port itself and you can do the settings in the VESC app. Right, so yeah, so what else do I have? This is covered. Yeah, this is about it. So basically you have to connect your hall sensor here, cables, motor cables to these 3 cables and sensor, and ignore this cable. This is for the other project that I'm still experimenting. This is a, yeah, you can ignore this. And you have a battery. Try to mount the battery in the center where it is not going to touch even if you flip the board. So this is definitely touching, so this is bad. Red flags because there is no casing here, so you need to put it. This is just a POC, right? So, and another thing is you have to make sure that the motor is at least 500 watts in power, because this was very underpowered. So I had to ride it upside down. So I was planning to ride it like this, where I keep my foot here, but since yeah, actually the motor requires a lot of torque if your axis on which you stand is above the center of the motor. So it's like some physics there. So what I did is I flipped it over so that I'm standing here and my axis is actually on the center of the motor, or even little below that. To get that even the small margin, I had to cut this into these pieces, and I'm standing here so that my axis is below this center, so that I can manage with the power that the motor comes with. So yeah, that worked clearly like you saw it in the video. Yeah, this is about it, guys. Good luck with your build. Yeah, bye bye.